Welcome to part 2 of our Chapter 8 practice test. Again, this is dealing with rational functions. We're picking up here at number 10. What we want to do is simplify our sum here and also make sure we state any restrictions on the variable. The very first thing we need to do is to factor our denominators. The x squared minus x minus 6 will factor as an x minus 3x plus 2. The x squared plus 4x plus 4 will actually factor as an x plus 2 squared. So we also need to identify that the LCD would include an x plus 2 squared and an x minus 3. Since we want to add these together, we need to get both of those to have that for their denominators. So the 4 has the x plus 2 squared, it does not have the x minus 3. So we multiply top and bottom by the x minus 3. The x has the x minus 3 and it has an x plus 2, but not an x plus 2 to the second power. So we multiply top and bottom of this by an x plus 2. So we need to then simplify our numerators. On the left-hand side there we would get x squared plus 2x, and that'll be over the x minus 3, x plus 2 squared. And we'll add to that, and we will distribute the 4 into the x minus 3, so we get 4x minus 12. Again, that will be over the LCD. And we've got some terms we can combine there. Let's see, so we end up with the highest degree term is x squared, and we'll get a 6x, and then subtract 12. And that will remain over that x minus 3 times x plus 2 squared. At this point we would want to consider factoring the numerator to see if anything could cancel out with the factors in the denominator. However, x squared plus 6x minus 12 just does not factor. So this is our simplified form, and we end up seeing that x cannot be 3, and x can also not be negative 2. So that's what we're looking at for number 10. So now I'll take a look at number 11. Again, there's a little bit of factoring we can do with those denominators. We can take a 3 out of 3x plus 9. That gives us x plus 3. And we can take an x out of x squared plus 3x, and we get an x times x plus 3. Our LCD then has to include a 3 and an x, and then an x plus 3. Again, we multiply each fraction by what it's missing from that LCD. So this first one is missing an x. Let's multiply top and bottom by an x. And the second one is missing a 3. Let's multiply top and bottom by a 3. We end up with x squared over the 3x times x plus 3 minus 9 over the 3x times x plus 3. So now those denominators match, and we are prepared to combine the numerators. Although there's not a whole lot of combining that happens since there's no like terms. All right, now you want to be careful at this point because, of course, our numerator here is a difference of squares. So we want to make sure that we factor that using that pattern. So, of course, that factors as an x plus 3 multiplied by an x minus 3. And so that x plus 3 will cancel out, and we are left with a simplified form of x minus 3 over 3x, and that is all we can do with simplifying that one. As far as restrictions for this one go, x can't equal 0. We can see that from our 3x right here, but also we had that x plus 3 in the denominator. So x also cannot be negative 3. So even though that got canceled out, it still provides us with a restriction on the variable. Alright, so number 12 and then 13 eventually, we're going to simplify the complex fraction. We've got a couple of options here. Again, one is that we could identify that the LCD for the whole entire complex fraction is x, and we could multiply both top and bottom by that. So let's take a look at how that would work. So multiply top by x, bottom by x. Now on the top we have a sum, so the x would distribute across. Now what we end up with then would be x plus 1. The 1 over x would just cancel the x out, so we're just left with a 1. And then in the denominator, just multiplying 3 over x by x would cancel the x out. So we're left with x plus 1 over 3. So that's one way to get that figured out. A second way that we can do that is we could focus on that 1 plus 1 over x. I'm just going to make that a 1 over 1. So the common denominator we would need in order to add those together would be x. So we'd multiply top and bottom of the 1 by x. So that leads us to x over x plus 1 over x, which then brings us to x plus 1 over x. So that's our numerator, and we needed to get that to be a single fraction in order for this other process to work. So then what we do is we take our numerator, the x plus 1 over x, and multiply it by the reciprocal of the denominator. So we take the 3 over x, we flip that over, that would be x over 3. So then we can see that those x's would cancel, and we're left with x plus 1 over 3. So whichever way you decide to do that, I think you can see that the first one worked out very quickly. It doesn't always quite work that way, so if you want to use the other method, that's perfectly fine. I believe it's good to know both because I think sometimes one is going to be better than the other. So, speaking of one method being better than another, here it might be kind of a mess. Really not kind of a mess, it'd be a pretty big mess to try to multiply the top and bottom of this complex fraction by the LCD. Partly because if you look at the LCD for the entire thing, it has 4 factors in it. Each of the individual pieces that would be getting multiplied here only has one of those factors, so you'd be multiplying each of those numerators by 3 of them, and that would not be very much fun. So I would go with that second method that we just looked at, really treating this as 2 different questions, finding the sum of the numerator and the difference of the denominator, and then the final part is multiply what we get in the numerator by the reciprocal of the denominator. In that numerator, we have a common denominator of x plus 2 times x minus 2. So LCDN for least common denominator of the numerator, x plus 2 times x minus 2. So each of these, again, gets multiplied by what it's missing from that common denominator. And so we end up with a 3x minus 6 over that common denominator, and a 5x plus 10 over that common denominator. And so we end up combining those like terms. We get 8x plus 4 over that common denominator. One last thing to do there, since the 8x plus 4 can be factored, we'd want to see what that turns out to be. So we get a 4 and then a 2x plus 1. Doesn't reduce yet, but we may come up with a 2x plus 1 in our denominator. We don't know quite yet, we haven't even really started looking at it. So this is our numerator. So I want to keep track of that, even though it's not, again, necessarily the final answer, but its first stage of this is done. And so when we go back and look at the denominator, so the 2 over x plus 1 minus the 3 over x minus 1. So again, that minus, you got to make sure you keep that in mind. LCD here, x plus 1, x minus 1. So we multiply each piece by what it's missing. And then an x plus 1 here. Let's see, so in the numerator with the 2, we get a 2x minus 2 over the x plus 1, x minus 1, and then minus the 3x plus 3 over the x plus 1, x minus 1. From here we can go ahead and find that difference. Again, make sure you remember that you are subtracting here. Let's see, so we would end up with 2x minus 3x would be a negative x, a minus 2 minus a 3 would be a minus 5, then we get x plus 1, x minus 1. Now, I don't really want to leave that as a negative x minus 5. I would factor a negative out of that and write that as the opposite of x plus 5. Now, oh, and for some reason up here I wrote an x minus 1. That's my mistake. That should have been an x minus 2. So then this is our denominator. So again, last phase of this is that we take the numerator, the 4 times 2x plus 1 over x plus 2, x minus 2, and we multiply by the reciprocal of the denominator, x plus 1, x minus 1 then is on top. I'm going to put the x plus 5 on the bottom. I'm actually just going to take this negative and put it up top on the 4. Again, it's a fraction, so we can move that to either the numerator or denominator, and I just believe that looks better there. And then really, again, a fraction times a fraction is just one big fraction. So I've got a bit of a gap here between my 2x plus 1 and my x plus 1, but again, if you scrunch that together a little bit better, then that's what we'd be looking at for how to write that answer. So I'm just going to scoot that over. And so it would look like that. And again, nothing cancels out, otherwise we would be reducing these pieces down.